Thanks a lot, Jose Miguel, for this opportunity of participating in this forum with this distinguished audience. I hope you will enjoy the show. At the end, it's just a biased experience I can provide to you based, yes, on my personal career. So consider it as a glimpse of what you could have if you abandon, let's say, the academic world. Yeah, abandon is a big word, but well, sometimes you need to get used to that. Okay, so and it's not a negative word at the end. So I will start sharing my screen. This talk is quite based on a talk I gave in the European School of Magnetism in I think it was on the 2017 or 2018. So if anyone was at this talk, sorry for that. But it has been updated with new data at least. Okay, so I hope you all are seeing my screen. Okay, the title is A Biased Industry Perspective on Basic and Applied Research and the Personal Experience from a PhD in Magnetism in an Engineering World. Okay, this is well, this is my email address if you want to contact me in the future. I work for Airbus Defense and Space, and this is the prepare, as Jose Miguel mentioned, for the expert for the non-academic world. So let's start. The academic, well, the executive summary of this talk is just is based on this, and this is a few points. It's aimed at highlighting the career paths that are beyond the academic research institution, which is to be the let's say orthodox way of continuing with your research career, which is quite good for sure. I will provide a frame for the actual needs that a private company has on research. You have to look for added values, meaning added value, whatever it takes, just to enhance your products and gain customer. Getting more reliable, and at the end, well, survive, as I will say, in this competitive world. I will offer a subjective view of the engineering scope of projects and research. As I say here, this is cost and schedule implementable, or just burst, abandon it again. And well, perhaps helping decide yourself whether it's worth giving a try to apply research in a private company or out of the academic world. At the end, it aimed also at fostering some kind of discussion on the desirable relationship that could be sustained between the research institution and industrial companies. I'm talking of which I put this comic here from the Upturn microscope, which is quite unveiling, quite relevant, quite funny about the relationship between research institutions and private companies. This is a private company, Personal, that has seen this the promising CV from a researcher. And well, he started talking about the possibility of joining the company. And well, he claims that perhaps it goes against its liberties, freedom for researching and publication, and that's it. No, he doesn't want to see his academic freedom limited by their commercial concerns. At this point, his boss from the research institution bumps in and says that, well, start writing a paper as soon as possible with what you can get from another group and try to publish it. Okay, so at the end, it's the opposite side. It ends saying that perhaps you mind having your commercial concern limited by our academic freedom. That's more or less the different paths that seems to be diverging when we're talking about research institution and private company research. Okay, so the talk itself, it has three main parts. First, it will be just a brief CV presentation from myself. Okay, later on we talk about Airbus, and then Airbus, and then Airbus. So sorry for that, but the point is that I work in Airbus, and I'm proud of that. And I will you I want to share with you which is the experience of working for such a big and private company at the end. And on the final part of the talk will just be a summary of the conclusions. Again, personal conclusions, so it's very subjective, very biased. Okay, so let's start. Well, I'm 50 years old. My professional experience is just limited, quite limited, because I've been from 2001 working on Airbus. Now it's called Defense and Space Business Line. Before it was division. Before I was group. Before EADS. But at the end, it's the same company at all. And before that, I did some 6 months after I finished my thesis, and I used to work on the Complutense University of Madrid as a technical researcher on railway EMC characterization, as Jose Miguel has already mentioned. On the education, well, I'm doctor in material physics, graduated in fundamental physics, and after that, I participated in a business school program called Vivero, just within the company. As the predoctoral research activities, well, my thesis had to do about dealing with magnetic anisotropies on thin films and multi-layers ground by sputtering. It was awarded with well, this extraordinary mention. There was I had in the past one patent approved on anisotropic magnetic resistance, and 32 referee papers at that time, including this 3 physical review B and applied physics and all, and 5 journal applied physics. I elaborated some procedure and later on the testing on radiating electromagnetic emissions on the high-speed railway. At that time, the unique high-speed railway that existed in Spain, the Madrid-Sevilla line. I participated in this other project in the multiple simultaneous code music funded by European Union. And I also participated, as Jose Miguel said, on the analysis of magnetic perturbation generated by a subway line of Madrid under the hospital that was nearby. All this experience was obtained from the Instituto de Magnetismo Aplicado Salvador Velayos in Las Rozas de Madrid, which is dependent of the University Complutense of Madrid and the CSIC institution. So the thesis, just for fun, just to remember what I did in the past 20 years ago, it was devoted to magnetic anisotropies, either induced by thermal stresses or just with some calculation for magnetocrystalline anisotropy. So I played with amorphous samples, zero magnetic restriction. Well, sorry, you have to help me here. Magnetic restriction here is negative, here is positive, isn't it? And here is? Okay, well, let's keep the mystery. Okay, the point at the end is that I played. Yes, sorry.
No, I think it's positive.
Okay, thank you. I played with the stresses and thermal treatments just to get funny figures of the thin films grown by these bended conditions. I also mixed negative and positive magnet restrictive material just to produce multi-layers that when they are submitted to stresses or ground under the stresses, they start behaving in such a weird way because there is a let's say a variation, an angular variation of the easy magnetization axis as you go up of this or go down of the depths across the depth of the multi-layer itself, and it did also produce some normal magnetization component. And for the thesis, I also just performed with Rafael Casero these calculations on the iron palladium order alloy that obtain a value of the magnetocrystalline anisotropy, and just was able to unveil that there was a slight magnetic polarization of palladium, as you can see here. This was my thesis. And after that, well, I can say that, well, the period I spent in the tertiary has been the most joyful years in my professional life, for sure, because of the people, interest, as you can see, challenge, travels, create a unique moment, very special people there, as you can see here, also in the audience, since they accompany myself 20 years after that. So once the thesis was finished, this is a period of uncertainty, and this uncertainty grew, and I had to do a decision about the future. There was very limited in time perspective that was at the end not very optimistic, just for continuing with the academic career. Because, well, as I say, it was a pessimistic forecast on reaching academic research career. No clear postdoctoral position. I just came back from France when I read the thesis, so I was not in an easy position myself. And yes, personal feeling by experience from other people that there was a kind of non-correlation of academic merits with actual attainment of academic position. That's hard, but it happens from time to time. And the idea of jumping from one temporary contract to another in the near future didn't seem promising to me at that moment. So I decided to try an industrial world, saying that, well, I've got a doctorate in magnetism, extraordinary work, I will find a job very, very easily. And the truth is that, well, it cost me 3 months at the end, but it was 3 difficult months. And what I can say you is that the PhDs are not very or extremely interesting for the industry per se. Okay, because at the end, this deep specialization narrows the job market. And in fact, as José Miguel has pointed out, I was contracted in Airbus just due to a line in my CV dealing with this electromagnetic radiation testing we performed in this high-speed train line. So as I was saying, it was a lucky non-void intersection, and I started working on Airbus. So let's talk about Airbus for a moment. Airbus is well, it's a big company that makes things that at the end fly in one way or another, in the atmosphere or beyond the atmosphere. And well, these are the key figures of the company. It's for sure is the largest European-based aeronautic and space company. It manufactures aircraft, helicopters, satellites, launchers, let's say Ariane, electronics, security solutions, and services. Okay, workforce, we are about more than 130,000 employees, 140 nationalities, over 20 languages spoken in the company, only one official language in the company, which is the English. And the world presence, it's 180 locations, but and final assembly lines, that is the places where the final products are being assembled and tested for flight and then delivered to the customer, are in Europe, in America, and in Asia. You can see, as a summary of the company taken from just the web page of Airbus, more than 2,000 aircraft delivers, around 2,000 also helicopters, the top 10 defense company, one company in the top 10 defense market, second largest aeronautical company in the world, behind Boeing, self-financed research and development of 3 billion euros per year. We are committed with the reducing the CO emissions, and we've got around 30,000 patents. So big company at the end. Big numbers from 2020. You can see 2020 hasn't been a good year for nearly any company in the world, but for transportation, it has not been a good year, as you know, because of the pandemic. And in fact, the EBIT reported was negative, that is in 2020, compared to the one on 2019, which was about 1 billion euros. Okay, but nevertheless, I mean, this is let's say another big numbers that tells you about how interesting is the company. Number of employees are, as I mentioned before, 130,000. And these employees require training, and these are the hours spent in training on ethics and compliance and health and safety. So this is a concern of the company about having a certain environment, healthy environment for the employees. You can see there are three main line of products within Airbus, which is Airbus Commercial, the big one, big brother, let's say. Airbus Helicopters, 12%, and Airbus Defence and Space, where I belong, is 21%. Okay, and this is our market spread around the world. And let's see the portfolio just very quickly. First is the portfolio is Airbus Commercial, okay, which basically delivers all the transport category aircraft you are used to fly on, together with Boeing. It's and these are the big families, 220, together with Bombardier, 320, 330, 350, new one, and 380. As you know, 380 we are not accepting any new requirement for new products at the end. Okay, so we are building just A380s that were already requested by customers. Okay, the Airbus helicopter business line, it has produced civil, military, corporate helicopters, and it has services associated to them. Okay, and Airbus Defence and Space, here you can see the Eurofighter. This is the figures of the company. At the end, the portfolio is quite diverse. It's military aircrafts, as you can see here, and security solutions and system assistance approaches with the future FCAST program. And for sure, you've got also these different families of satellite productions and services and equipment and launchers in products that we are developing. So this is the complete portfolio of the company. Figures, I will go quickly through that. These are the revenues by each of the business lines. I want only to point out that our expenditure in research and development is around 3 billion euros per year, as you can see here. On the business figures, you know that it has not been a very good year, mainly for commercial aircraft because of the decrease of traffic in general due to the pandemic. And in the helicopter and defense and space, we have more or less maintained the figures. On the how many people work for each of the business lines. For Airbus is the majority of the people. Then Airbus helicopters, 20,032. Okay, in the geographic area distribution of the employee mainly is split in for France and Germany with similar figures, 40,000. Then Spain went around 11 to 12,000 people. UK around 10,000, and for the rest of the world, this creates the sum at the end of 131,000. Okay, now after I've talked about the numbers, big numbers of the company, let's talk about something which is perhaps could be new or different from the research world, which are what we say the corporate values that every company has. And these are the ones, the values that are defended, are identified and defended by Airbus. And you can see here all of them. We are one. Customer focus, reliability, respect, creativity, integrity. These big words at the end has their sense because they do create a chain reaction within the company that makes that to use a definite procedure just to in every aspect of your work within the company in line with obtaining these six big values that you can see here. As an example, the We Are One value seems that the company makes efforts just to enforce the teamwork. You know that we are merged of companies in the past, so there's always an intention just to merge all the experience that is created around all the Airbus sites in order to avoid silos. So that's what's behind the We Are One. For sure, we want to be focused on the customer, because at the end, customers is the people who pays and who keep us alive. For sure, we take very seriously the reliability of our products. Okay, because at the end, it's a very competitive world, and we want to be reliable in front of the customer. Our products, I will deliver at the end, and delivers quality and delivers safety. That's the point behind that. For sure, on the internal work environment, we need to treat each other with respect, embracing diversity. Okay, that's a very strong value within the company. Okay, and for sure, creativity is related to all the efforts and the expenses at the end that is focused on research and development at the end. Just backing all the creativity of the employees, and for sure the integrity, because you need, for being a long-standing company, you need to be to have integrity in your behavior. Okay, that's what's behind these values. Okay, so let's focus now on the research activity in the industry. It is a kind of research very applied, for sure, and driven really by the strategy of the company. At the end, the main objectives of the industrial research and development activities are, for sure, to create new products and services. That's all. Okay. New products and new services that enhance, for example, safety, reliability, quality. At the end, they reduce the cost of the production of your item, increase profit, for sure. We mustn't forget that. And also, the research and development activities serves just to forecast the future's evolution of the market. You need to be at the state of the art of the technology in order not to be left apart. Okay. But not only forecast, but also influence. And the slight difference here is very significant, because you need to be the state of the art of the technology. You need to be leading the state of the art of technology. And we are trying always to be at the lead of every single activity of research and development. For sure, it serves research and development activities just to keep the technical knowledge and capabilities of the employee. Okay, and at the end, it's only one word, just to survive as a company. Other objectives that are considered spurious, which are, for example, the compulsion to unveil secrets to the natural world, which is something very attractive from the basic research collective. No, I mean, we want to do research just to unveil secrets, to understand why nature is as it is. For sure, curiosity. For sure, altruistic contribution to enlarge the scientific knowledge, and other less, let's say, or narrow objectives, such as increase the number of publications, get a permanent academic position, of attaining funding for grants and projects. All these objectives you can see here are spurious unless they contribute to the first set, unless they contribute to the company for the company's survival. Okay. Also, this research on the industry is for sure driven by the strategy of the company, but also it has some contribution, some alignment, as I say here, with big values that are being developed and need to be searched in the long way, and even at the UN forum, like foster education, gender equality, decent work, industry, innovation, and infrastructure. For sure, maintain peace, taking action on climate, be responsible, and the corrupt responsible consumption and production, recycling efforts, okay, and all that. So these are big words, what I mentioned up to now. But now let's focus on how we articulate that. At the end, for sure, as any company with similar structure, we've got mapping of technology with some road mapping just to deliver and to just focus on different to planning the development of different technologies. This planning and road mapping are inputs, apart from inputs taken by the strategy of the company, and for sure the division, the needs and resources of the divisions. And at the end, they lead to several research lines. You can see them in the web page of Airbus. Again, I put here just some basic example of that. One of them for sure, and in commitment with the climate actions, and just to decrease the footprint of the combustions of wells. We are developing, you may have noticed, zero emission aircraft for the future. That's a plan. These are different models that are this is the roadmap for the use of hydrogen towards aircraft in the future. The different models that are just being investigated now. Sorry. Okay. Another example of research is just focus on the division I work in, is the automatic, what we call automatic ITER refueling. We build some aircrafts, that are able to deliver fuel to other aircrafts while in flight. Okay, this is what we call the AC-30 RTT. It has 3 positions to just dispense fuel. One of them is this so-called the boom system. And what we have developed up to now is an automatic recognition of the fuel receiver, making this operation fully automatic, increasing safety and sure. Either with big or small aircraft. This is another example of a successful research and development initiative. We are just going to certify this year. Okay, sorry for the music. Okay, now going to my personal experience. I don't want to bore you just to the permissible amount. So, okay, just going to my position on Airbus. Within Airbus, I work for the division of Airbus Defense and Space. I'm based in Getafe, Madrid, Spain. And in the post belongs to system engineering. It's a transversal activity, which is the electromagnetic. My professional role is expert in electromagnetic hazard protections. I work for military aircraft, mainly this AC-30 RTT, the one you have just in the video. And my activities are just linked to oriented to provide adequate protection to the aircraft electronic installation and structure from the electromagnetic environment in order to ensure airworthiness and capabilities of the aircraft during its life cycle. So electromagnetic environment at the end is just the natural and artificial electromagnetic field levels into which the aircraft is immersed during its operation and needs to fly therein in a safe way. Okay. It encompasses what we call the high intensity related fields, which are generated out of the aircraft, for sure, lightning events, electromagnetic pulses, electrostatic discharge, and other electromagnetic field levels that are being generated by the onboard equipment. And for sure, airworthiness refers to the condition of safe flight. You are able to produce a thing that is able to fly whenever you put it up there. You want it to be to keep flying in the same manner. That's a very important part, the most important part of our work. Okay. And this process is what we guarantee through the airworthiness and through the certification of the product in front of official bodies, such as EASA, FAA, or equivalent. Okay. So system engineering consists just on building a product that meets certain requirements. Easy. This requirement just, well, our task just consists on converting the user needs of the customer that comes to us saying that I want an aircraft that is able to do such thing, okay? We deliver with them the top level requirements, and on our own, later on, we create a cascade of other requirements that are oriented to define some design solution at different levels of the integration of the aircraft, which is final platform, equipment, structural elements, system assembly. And once we have defined a design solution that meet the certification requirements and also the requirement from the customer of being able of doing something while in flight, we need to demonstrate that the product is able to meet this requirement. So that's as interesting and as boring as I'm saying. Okay, but I think it's mostly interesting because its project is different. Okay, so we need specific competences on the protection from the electromagnetic environment. Okay, in order to ensure immunity to electromagnetic interference and to prevent and control the electromagnetic field propagation. We need to address, generation of the electromagnetic energy, absorption, reflection, shielding, whatever phenomena is you may remember about electromagnetic fields propagation. So let me present now some more technical information on which is my day after day work at the company. Okay, so I hope not to be very technical there, but one of the objectives of the work we are doing in our electromagnetic compatibility department is just to ensure that the aircraft is able to fly in a safe manner whenever it is submitted to the electromagnetic fields created by other aircrafts, by ships, by terrestrial, by ground stations, near the airport, out of the airport, whichever. Okay. In order to do that, you need to certify the aircraft by saying that it can fly on a HEAF environment. This HEAF environment is dependent on the scenario the aircraft will be immersed. Okay, well, at the end, we need to protect the aircraft from the currents that are being induced along the structure and the systems whenever electromagnetic field is approaching the aircraft. That's in the way you could see here. These are superficial currents that are being produced just by a plane wave illumination of the aircraft itself. That's seen from the exterior, and from the interior, you can see here that it's the same induction. Sorry. But here you can see cabling inside the aircraft, and you can see that they also change the color, meaning that there are some induced currents that are being induced in this cabling, and therefore they arrive to the equipment, and they can let's say stress the proper behavior of the equipment itself, just by adding some noisy environment there. Okay, another thing more spectacular. It's the protection we need to provide to the aircraft systems and the structure against lightning. Okay, so I will tell you some small words, a few words about wording, about the lightning phenomena and its interaction with the aircraft. First of all, it seems that an aircraft is a big bird and a big system and complicated. But when you see that, you could see how small an aircraft is.
Wow.
At the end, you need to protect the aircraft and make it still be robust enough to continue flying, as this aircraft does, even in front of such a spectacular impact of the lightning in the aircraft. Okay. Lightning, something we can say about lightning. Well, it's mainly produced on the thunderstorms, okay, cirrus-ambient clouds like them, where there are very dynamic processes with very strong winds within the clouds that produce a lot of friction between the particles and create very different charge centers within the cloud that needs to lever somehow. And the way they do that is through lightning at the end. And there are some statistics done in the past with planes flying near thunderstorm that predict some kind of distribution of lightning whenever the aircraft is flying around these kind of clouds. No? At the end, these statistics tell us that each aircraft receives a lightning each 2,900 hours, more or less, which is the typical hours that a commercial airliner makes in 1 year. So in average, an aircraft receives a lightning once a year, and you want the aircraft to continue flying several years, no, and keep the people safe within the aircraft. So let me give an example.
A massive lightning strike hits this Airbus A380 as it comes in for a landing in London. Despite the jolt, the 500 people on board and the plane are all fine. No injuries or damage. In February, a JetBlue flight was hit too on approach to Boston.
We've been struck by lightning twice. There's a smell of smoke on the airplane, no other indication this time. We need as expedited approach as you can give it.
Each year, while the odds of being struck by lightning on the ground is 1 in 700,000, the odds of being aboard a plane that struck is 1 in 1,250, 560 times more likely in the air. Former Captain Kevin Hyatt knows that well.
We were on the approach. We saw a bright light, and then you hear this very, very loud crack.
So what happened when you got on the ground and took a look at the plane?
We took a look at it, and I was really fairly surprised to see the small brown and black pock marks all the way across the fuselage, which really meant that, you know, we did take a pretty good strike.
It was just cosmetic damage. Usually, if there is damage, it's minor. That's because a plane is designed to withstand lightning. Say a bolt of lightning hits its wing. Rather than burning up the wing, that bolt of electricity is deflected. It races along the plane's aluminum skin and eventually off into the atmosphere.
When you're in the air, the way this is made, it would just bounce off the side.
Bounce off the side of the fuselage.
Correct.
And all of the critical systems on a plane, wiring, electronics, fuel tanks, have extra shielding to guard against any possible damage from lightning. While the collision between an airplane and nature may look spectacular, because of all the protections, it has been nearly 50 years since a plane in the U.S. was brought down by lightning.
This news explains very well the phenomena. Okay, so as you can see, what we expect at the end is just to have cosmetic damage that can be repaired once the aircraft is landed again. Okay. More things about lightning. Well, there are a lot of flights in the world, okay, across the day, and it's a very small single yellow dot there is submitted, maybe submitted to some lightning during the flight. You can see here the very big amount of flights that occur daily in the world. It was a pre-pandemic graph. That's it. So just noticing. Hope to recover it soon. Here you compare number of flights per day with the density of lightning impacts in a certain in all the areas of the world. Okay, as a curiosity, please have a look to this Catatumbo lightning, which is quite amazing lightning, kind of quasi-permanent lightning phenomena that occurs near the Maracaibo Lake in Venezuela. Between Venezuela and Colombia, it's quite funny phenomena, and a significant producer of ozone to the atmosphere. Okay, so to continue and finish with lightning, I would say that in order to design our aircraft and protect it against lightning, we need to put some numbers to the lightning phenomena, and these are the numbers we put to the lightning phenomena. It's just curiosity for you to know, and it's so a lightning for aeronautical engineering, something like that. This is the current driven through the lightning channel, and you could see that you've got a very big increase of current in what we call the component A, which is the moment at which any lightning completes the path that allows it to get actual electrical current, electrical charge transferred from one place to another. So this is what we call the component A, and it carries around 200 kiloamps. Once the channel is created, the charge use this channel just to discharge itself. So through all this, what we call these slow components, B and C, and later on, perhaps during the lightning phenomena, another charge centers that are nearby in the clouds where the lightning has originated may use also this channel that has been created just to discharge themselves, and that's what we call component D. We need these numbers in order to protect and to design against this number and to certify against this number with the authority. This is an example of the lightning dynamics, just for you to know. You could see here is a lightning air band electrically disrupted. The lightning is just looking for a path just to go to ground. There, this very brilliant instant is what we call the component A, and you can see here the channel is maintained from time to time. There is an increase in the luminosity, which means that there are another charge centers that use the channel just to discharge. Okay, this is a lightning phenomena, and we need to put an aircraft on the picture, the video, and design it just to withstand all this energy that is being transferred through the aircraft. Okay, what happens when a lightning hits an aircraft? Well, it can happen two things, what we call direct and indirect effects. Direct effects are all the damage produced by just the passing of the current through the lightning current through several parts of the fuselage from one point, entry point, to the exit point. You need to be sure that you are not creating ignition hazard just for the aircraft blown up with a full tank. For sure, they create very strong magnetic forces that tends to narrow together the distance between nearby conductors. And for sure, it does create just hot spots and all this damage that needs to be repaired. When you are using, instead of aluminum fuselage, carbon composite aircraft, which is less heavy than the aluminum aircraft, you need to protect it against serious damage of the carbon fiber itself, and you need to protect it with several metallic meshing, just to avoid creating some holes even in the structure of the aircraft. And for sure, you need to protect this. You need to avoid the creation of electrostatic of discharges at the end of certain points of the aircraft, mainly if these points are within the fuel tank. Okay, you don't want to have it. These are what we call direct effects. And in order to design properly the aircraft against this damage, what we do is just to put identify the aircraft and let's say divide the aircraft in different zones with respect to the probability this zone have on receiving the initial impact of the lightning. Okay, that's what we call zone 1, zone 2, or zone 3. Depending on the zone, you have to design in a proper manner just to deliver just for the structure to deliver without any damage, any serious damage, this current from one side to the other side of the aircraft. Okay, sorry. Another thing about the lightning is what we call the indirect effects. Has a lot to do with magnetic protection also. Indirect effects are created because of the very high induction that a quite fast changing current passing through the aircraft. Let me rephrase. Whenever lightning hits an aircraft, there is a very fast changing lightning that passes through the fuselage of the aircraft. It does for sure creates a magnetic field that changes very quickly with time. So you've got an electric field also, you create a very inductive source of noise into every single piece of electrical wiring in the aircraft. So at the end, you are producing a lot of electromagnetic forces within the aircraft, and you need to protect every piece of equipment against all the transits that will be delivered to the equipment because of the lightning impact. This is what we call the indirect effects. And then finally, I would like to talk to you about how do we protect against what we call the portable electronic devices. I hope you have known that about these all these electronics that every passenger has now with them when they go up on board an aircraft, such as mobile phone, tablet, laptop, carried on board. And the funny instruction you have to follow just to put either the aircraft mode or just switch off in certain flight conditions or whatever. No, we need the people in charge of giving certain recommendations and limitations are ourselves in the electromagnetic protection area. And you have to take into account that, for example, here there's a simulation of a GPS signal being produced within the aircraft, that through the apertures of the aircraft, this GPS signal, or let's say no GPS signal at the frequency of GPS can produce interference on the GPS receivers that are that may be located around these areas. So having such an internal source of interference may produce the aircraft to be confused about where it actually is flying. So that's an important issue. Okay, so what might be happening during safety briefing to passengers in commercial flights? Let's have a look to that.
Ladies and gentlemen, as we prepare for takeoff, please turn off all electronic devices.
Why?
What's that?
Well, why do we have to turn off our electronic devices?
Because they can interfere with the plane's navigation.
Oh, okay.
So anyway...
How?
What's that?
How do they interfere with the plane's navigation?
Oh, because the electronic signals can interfere with the signals between the plane and the radio tower on takeoff and landing.
Oh, okay. Gotcha. That makes sense. Thank you.
Okay. Let's all make sure that our seats are fully upright.
Wait. I mean, I get why I can't have a radio or whatever, but how is my Kindle going to screw things up?
That's a good question.
It's not just about radios. All devices have an electromagnetic field that can interfere with the radio frequencies.
Okay, that's cool.
All right, please make sure that all tray tables are...
Wait, so you're saying that a $90 million aircraft can't ignore the signal from my $40 iPod Shuffle? That's weird.
She's right. That is weird.
Yeah, now I'm confused again.
If they're so dangerous, why do you allow devices on the plane and not, I don't know, gels?
Yeah,
Could I hold this plane hostage with my 3DS?
Some devices are more dangerous than others, but there isn't enough time to go through them one by one.
I mean, how come the plane doesn't interfere with my phone?
And why don't the other phones interfere with my phone?
I just always leave my phone on and nothing happens.
You can't! Everybody, no! All electronic devices have to be turned off.
I can't turn off my pacemaker.
Well, your pacemaker is fine.
It just opens up a whole new can of worms.
Airplanes are magic! Okay. No one knows why you have to turn off your phones, and you want to know why? Because no one knows how an airplane works! A couple of dumbos down in Kitty Hawk took some sticks and some old pants, and they glued them together, and they fucking flew! And no one knows why.
I thought the wings generated lift.
Lift? Thrust? No. Scientists want you to think that they figured it out, but no one has ever figured it out, and now we're just rocketing through space on a 30-ton dumpster running on God knows what magic, and you guys want to just dick around with that? I mean, who knows what could fuck this shit up, okay? So turn off your Twitter machines for just 13 minutes while we soar through the clouds like the sun god Apollo and just read your fucking sky malls! Okay?
Okay. Fiery. Okay.
Hey, my sister is pregnant!
Hey, if you like this video, click me to subscribe.
They are quite good, and well, they have presented the topic in a very accurate way. Okay, let's let me explain what are we doing related to this topic now. Let's put again series. So in order to check whether the portable electronic devices do affect with our airborne systems, what we do is just divide the coupling it can have on front door and back door, meaning that the front door, well, the front door stands for, you have here the PD emissions and the airborne victims. So the PD emission could be intentional, and they are intentional when we are talking about Wi-Fi, about 4G, 5G, or whatever. Bluetooth up to a point. And these are intentional radiation from the PD that may affect the antenna of the aircraft. So whenever the affected system is an antenna, we talk to that, we characterize that as a front door coupling, because at the end, the antenna is designed to receive energy, even very small amount of energy. And the antenna is designed to receive that for the equipment installed behind the antenna to process that and make use of this information. So at the end, we can have this kind of coupling, intentional radiation to antenna. If this intentional radiation go to some units and equipment that has not any antenna embedded or connected to, we call it ERU, or it has affect cables, we call it IRC, okay? If the PD emissions are non-intentional, that means whenever you put your phone on an aircraft mode, okay, you are just emitting electromagnetic noise just because the equipment is functioning, is operating. But the amount of energy is much less. So this could be radiated, and it can affect again the antenna, NERA, the units, NERU, the cables, NERU, okay, NERCs, okay. So do we need to worry about all of them? Well, the connected, if your PD is connected just to power it up, whatever, to charge it, we only need to worry about these four things, because these are the ones that has more probability to produce any malfunction of the airborne systems. The amount of energy involved in this phenomena are quite small. It's quite small just to consider them as a real danger. So with these four potential dangers to the aircraft that we need to protect, we need to mitigate, let's say, there is one that it does not apply at all, which is this one. Is intentional radiation to antenna. Why is that? Just because the frequencies used by the portable electronic devices are quite different from the frequencies that this airborne system are able to transmit and receive. You know that there is a world organization just devoted just to limit or just to split the electromagnetic spectrum into different areas for developing different specific services. And the aircraft services that use all the aircraft navigation, identification, and some radar systems work in frequencies spectrum that are limited to the aircraft aeronautical industry. So no portable electronic device can transmit within this frequency range. However, this intentional radiation can affect units directly, or can affect cables, or the non-intentional radiation, which are smaller in amplitude, but they could also affect the antenna, since they are designed just to receive and process very small amount of energy. So from your mobile phone in aircraft mode, you can affect an antenna in the aircraft. That's why it's another representation of the same phenomena. I don't want to enter into that, but just for you to know that the intentional radiation of what we say transmitter portable electronic devices around 10 volts per meter at 1 meter distance, and however the non-intentional are just 100 times smaller than that, just 100 millivolts per meter. Okay, that's concerning the technical work on the civil world. On the military or defense aviation, you have also to protect the aircraft against what we call hostile electromagnetic threats, since let's say the defense operation nowadays involve a lot of systems working together in a coordinated manner. In order to get all these systems being coordinated together, you need to transmit and receive a lot of information to and from them. So at the end, the radioelectric radio frequency environment has become an actual warfare tool and a battlefield itself. At the end, you need to protect your system not to be jammed by hostile counterparts, okay, in order to avoid you just to forget where you are, or just being targeted by a radar or whatever, okay. So that's another big field of work of our discipline in defense and space. Another example of a hostile electromagnetic threats are just the electromagnetic pulse themselves. You know that the electromagnetic pulse could be of nuclear origin. It's a curiosity, but since it's a curiosity, I tell you about that. If a nuclear detonation is performed in the atmosphere, for sure it does produce a lot of gamma rays, ionization, that what's produced at the end is it does sweep away the external electrons of all the surrounding atmosphere that are in the blast area. So it does generate a lot of charged particle can whip away the nucleus of the atoms. It that creates, for one side, ions, and for the side, electrons. And these electrons has a lot of energy and are moving quite fast. And at the end, even more, these electrons moving quite fast are moving within a magnetic field, which is the Earth's magnetic field, okay? So at the end, they start producing some kind of helicoidal trajectories, okay? And these helicoidal trajectories of free electrons flying around the atmosphere along magnetic field line do create a very intense electromagnetic radiation itself, and that's what we call the nuclear electromagnetic pulse, and you need to be protected against that, okay, in the defense world. Another example is just these guns that at the end are able just to jam the signals of GPS receiver, data links of drones or whatever other equipment, just provoking them just to fall off. Okay, That's talking about hostile electronic threats. And now, just to finish with this part, let's talk now, sorry, about how much time do I have? Jose Miguel? I pass the time, isn't it?
Excuse me. If you can finish in, let's say, 5 minutes,
okay,
should be okay.
Perfect. Okay, so on the just talking about the technical career that you can develop within Airbus, you can select either the management approach, architecture, or the expertise approach, which from where I belong with in the expert career herein. And the what's an expert role definition within the company, it's as you see, a person who has some knowledge and skill in a field of competence which is important for the company. We are labeled as critical knowledge owner, and in order to be considered in such a role, you have some accountabilities and rights and some duties. Okay, so such growth, expertise, propose orientation from technical decision, provide advice, cooperate with other domain specialists, disseminate knowledge, deliver expertise at the end, and represent Airbus, which is the purpose of this talk at the end. The expert rights, we've got the rights just to investigate, just to participate in conferences and work in groups. We can represent Airbus externally. We have the right to listen and contribute on technical issues. We can take initiative on knowledge dissemination, and well, we have similar compensation benefits from in other branches. On the duties, we are resource of the group, so we need to go whenever the groups require us. We need to participate, identify research and development, well, all these things you can see here. And at the end, we need to mentor people internally and just to create value for the customer. Okay, and very briefly, I will talk about the what we call the soft skills that need to be developed within a big company such as Airbus because of this first bullet. It says that the complexity of this engineering project requires contribution for a very wide range of organization, constituted by a lot of people, each of them with unique personalities, background, characteristics, and concerns. So you need to apply certain skills that need to be developed in order to communicate with respect, integrity to any other person in effective, as you say, constructive and positive ways, and also behave assertively in relation with your individual needs and the needs of the company. Okay, and then, well, just to finalize, back to personal experience as an expert role, I've participated in some applied research activities. They are more modest, not oriented to publications. There are some small projects we have had with the CSIC in the past, just with thermogenic material. And well, the research did not end, as I say here, but it's changed notably in some publications in some EMC conferences and publication from IEEE. Also participation in internal forums, or research and technology forums, and well, I just give classes on them on an internal master we do have with in collaboration with a university, and we are participating in the elaboration of guidance material for the aeronautical industry. Okay, so at the end, conclusions. What is missed from the research world? From the academic experience, the thrill of discovery, freedom to define your investigation, work at challenging tasks. You've got a very beautiful work, to feel pain at the edge of something, to be able to explain behavior, conjecture, confirm, refute, question everything, and learning at every moment. But what is absolutely not missed? The insecurity of the academic world, long chain of grants, postdoc, temporary contracts, some kind of paternalism, perhaps, or arbitrary managerial decisions, favoritism. I'm just talking about the limited experience I had in the past about this academic world. So unfair treatment with no consequences, and this kind of childish relationship from time to time just become heartless in a way of conquering group A because just you work another group. Okay. So what is gain after abandoning the academic experience? Well, to work in a collaborative environment is not exclusive of the company world, but here it's mandatory. To participate in the creation of complex system, for sure, financial security, labor rights. You are accountable for your personal behavior. You can progress based on results and certain kind of well-being care from the company. What is penalized? For sure, this is a stress-friendly environment. This is running on and on to get milestone, endless cycles, and well, there's more precise objectives. At the end, just to finalize, your professional career stands on several pillars, which are your education, background, the commitment you could have, the decision of other people, good luck you could have, and conscious choices you do in the past, timing, opportunity, and also bad luck. So these are not completely under your control. So the only thing I recommend you, and sorry for that, but it's something that we see from time to time, is just to find your own stupid, let's say. You are a very clever bunch of people, but it's true that this kind of behavior, mostly in the engineering world, is of course this way. Maybe you reach your own stupid whenever you are fully confident of yourself and your knowledge, your background, but you are not skilled enough just to realize that you are not so skilled and you need some path to run before reaching certain level of confidence. Again, more based, more grounded. Sorry, that's all. Any questions? After, I would say the commercial in next page. So thanks a lot. And that's all, Jose Miguel. I can announce the IEEE if you want, or later on.
Sure. I'm clapping my hand and on behalf of all attendees, and please do the commercial. And then we will ask you.
Okay, the commercial is about the conference on lighting and static electricity we are going to hold in Madrid in the next year. It's being chaired by, it will be organized by Airbus Defense and Space in Madrid. And it will be held in Madrid in September. And these are the topics we are going to deal with. And for sure, you are invited to produce any contribution you may have on these topics. Okay, we are organizing it and with LCOE, the High Voltage Technological Center, University Carlos III in Madrid, Politécnica de Catalunya, Politécnica de Valencia, el INTA, and the MITS also. And well, Madrid, you know where it is, more or less. It's here, and here's the town hall, and well, we hope to see you here. Some technical information is available on the web page that is being on the construction, but it has the main dates nowadays, currently. And that's all. Thank you.